Hello students, welcome to this session where I've just solved this physics NEET test 70 released by NTA. Today the paper was released in the morning at 7:30, so I was not able to put it in the night. Many of you commented on my WhatsApp that what happened, sir, but because the paper hasn't arrived I couldn't solve it, because without paper how can I solve that? So now I have solved it, and because it has come late and because of the schedule I might be have hurried through the paper today, so sorry for that. Now in the today's paper there are some questions which are actually lengthy in calculation. So although I have written 21 easy, 21 medium, but it is not as easy, I suppose. 3 I have termed as difficult, and 2 I suppose the answers are not appropriately given in the paper. So let's see it what is in the paper. Before that I just the scores. If I say again, I'll say for an average student 130 plus, and for a good student it should be 160 plus sort of paper. And please, if you want the PDF, please fill in the type form given in the description box of the video. Okay, now let's begin the paper. Which one of the following statement is wrong in the context of X-rays? So wrong, you have to choose. Wavelength of the characteristic X-ray decreases when the atomic number of the target increases. This is right. Cutoff wavelength of the continuous X-rays depends on the atomic number. This is wrong. Cutoff wavelength only depends on what is the potential applied. It does not depend on the atomic number, so it's wrong. So move forward. Next one. According to the Bohr model, the minimum energy required to remove an electron from the ground state of doubly ionized lithium atom. You can directly say minimum energy required to remove. Remove, that means it's basically means ionize. So that ionization energy, what I can write is 13.6 eV z square. Z square here is 3 square, that is 13.6 into 9 eV. So that comes out as 9 6 what we have 54, 9 3 27, and 532. 919 122.4 eV. So go for option C. It's a direct application of the Bohr model. Next one. Gun fires bullet each of 1 gram with velocity 10 by exerting a constant force of 5 gram weight. Okay. Then the number of bullets fired per second is. So what is force here? 5 gram weight means 5 into 10 to the power minus 3 into 10. So that is 5 into 10 to the power minus 2 Newton. That would be equal to NMV. You know, momentum change per second. N is the number of bullets fired per second. So therefore what we will have, N would be equal to F upon mv, which is 5 into 10 to the power minus 2. M is 1 into 10 to the power minus 3 into 10. So this is 5. So it can fire 5 bullets per second from the given data. Now this was question number 3. Next, go for the fourth one. A ball kept in a closed box moves in the box, making collision with the wall. The box is kept on a smooth surface, the CM. Because it is kept on a smooth surface, there is no horizontal force, so the CM of the ball plus box system won't shift. So box plus the ball system is going to remain constant. Of the ball will change, of the box will change, but the combined CM won't change because no external horizontal force is there. Next. Toy car tied to the end of an unstretched string of length A, when revolved, moves in a horizontal circle of the radius 2a. Okay, with a time period t. Now the toy cart is speeded up until it moves in a circle of radius 3a with a time period t dash. If Hooke's law holds, then okay. So now what we have, when it is at 2a, 2a means the extension would be a, so that is ka would be equal to what I can say mv1 square by 2a. So here that v1 term, or it's better write it as omega square r, that would be better. That would be m omega 1 square into 2a. So omega 1 square was ka upon 2a, that is k by 2, and this would be m also. So time period we can take the ratio next. Next one, when it is 3a, the force would be k times 2a, and that would be equal to m omega 2 square into 3a. So omega 2 square will come out to be 2k by 3m. So what we have now, omega 1 by omega 2 we will have as, if we take the root, k and m goes, it would be 1 by 2, it would be 2 by 3, that is root of 3 by 2. So t1 by t2 would be reverse of that, that is 2 by root 3. So in the new case, the t2 would be root 3 by 2 times t1. So as per the given option, what you are getting, this is option number, what we are getting, has been wrongly given in the NT answer key. They have done a mistake here. They have taken it to be k, where the force here would be k times 2a, because the extension now would be 2a. Next one. A particle is given an initial speed u inside a smooth spherical shell 1 meter, such as it is able to complete the circle. Acceleration of the particle when the velocity is vertical. So it just completes circle. That means this u, you know, is equal to root 5 rg. Now velocity becomes vertical at this point, and you can, from energy analysis, you can say v would be under root of u square minus 2gr, that comes out as root 3gr. So at this point, what will be the acceleration of the particle? First, there will be normal would be equal to mv square by r. So a centripetal acceleration you can say is equal to v square by r, which comes out as 3g. And because of the mg in the vertical, it has an at component which is minus g, so net acceleration would be ac square plus at square, that is 3g whole square plus g square, that comes out as root 10g. So this is g root 10, don't do it as 3g because that is only ac. Net acceleration is ac plus at, vector form. Now the resistor in which maximum heat will be produced. So you see these three are in parallel, 6, 3, 2. If you do 1 by 3 plus 1 by 6 plus 1 by 2, or you can do, this is coming out as 6 and 3, 2, 2 and 2, 1 ohms. This is between, let's say this point is A, this is C, and this is B. So these three are in parallel, that is 1 ohm. These two are in parallel, that would be what you have, 5 and 4, that is 20 by 9 ohms. Okay, this is B, and you have applied this V. So first of all, if I divide the potential, what we'll have, this potential V1 I can say, or VAC I can say, would be equal to 1 upon 1 plus 20 by 9 into V, that comes out as 9 by 29 V. And V across BC will come out as 20 by 9 upon, what we'll have, 29 by 9 into V, that is 20 by 29 V. So clear cut, what we can have, we can write the heat generated as V square by R. So if I do that V square by R, it is clearly, it's very high, so it would be in 5 and 4. I can make out there will be more current in 5 and 4, and there would be more, what we can say, voltage is there. So if I take in 5 and 4, because they are in parallel, 4 ohm will have maximum power. You can calculate manually also by doing that, but I can clearly make out this is in the 4 ohm. Or if you wish, let's say, let me calculate it. In the 3 ohm one will be, I will have 9 by 29 square by 3. In this I will have 9 by 29 square by 6, and in this I will have 9 by 29 square by 2. So clearly we know 2 will have the maximum power, and for this 4 ohm what we will have, 20 by 29 square divided by 4. So definitely this term is greater than this, so maximum power will be in 4 ohms. You should be able to directly tell. Okay, next, in the circuit, power dissipation is 150 watt, then R is okay. Total circuit power dissipation I can write as IV, so I can directly say this current is 10 ampere. So this current is 10 ampere, total power is 150. So what I can make out, so this is 15 volt, current is 10 ampere, so the resistance would be, total will be 1.5 ohms. R equivalent, that means R into 2 upon 2 plus R is 1.5, or write it as 3 by 2. So 4R is 6 plus 3R, so R comes out as 6 ohm. So you can go for option B. Again, not a tough question for you. Next one, in a series resonant LCR circuit, voltage across R is 100, R is 1 kilo ohm with C 2 microfarad. Resonant frequency is this. At resonance, the voltage across L is okay. What we can make out, first of all, what is XC? XC is will be equal to XL at resonance, and that I can say is 1 upon omega C, that is 200 into 2, and that is 10 to the power 6. So that comes out as 10 to the power 4 by 4, or if I write it as 100 by 4 into 100, you can write it like this. So 100 by 4 into 100, that is 2500 ohms, 2.5 kilo ohms. Resistance is 1 kilo ohm. So what I can say, VC RMS at resonance equals VL RMS equals to I RMS into XC, and VR RMS is equal to I RMS into R. So if I divide it, what I will get, this VL RMS or VR RMS, this ratio is XC by R, which comes out as 2.5. So it would be 2.5 of that would be equals to 250 volts. So we'll go for option D for this particular case. Next one, an equilateral triangular loop ADC having some resistance is pulled with a constant velocity out of a uniform magnetic field directed into the screen. At t equal to 0, side DC of the loop is at the edge of the field. The induced current versus time graph will be. So what we can say, as it goes out, you can correctly see this progressive length decreases. So the change in EMF keeps on decreasing, and because of the symmetry it will decrease linearly, so that current will also decrease linearly with time. So I can directly go for, not for A, sorry, it is constant, I'll go for option B, because it is going to progressively decrease with time because of the proportionality, you can say, because in any time t, let's say this distance would be Vt, so this effective length will decrease linearly with the t if you do that symmetry thing. So directly you can make it out. Next, the arrangement of the charges are as shown in figure. Flux linked with the closed surface P and Q respectively are. P, you can say Q enclosed is minus Q, so that is minus Q by epsilon naught. This is plus Q, that would be plus Q by epsilon naught. That is what I am getting. That's a very easy application of the Gauss law. You cannot afford to lose that marks. Next, ring of charge. So, ring of charge with radius 0.5 meter has 0.002 pi meter gap. Okay, it has a gap. If the ring has a charge 1 coulomb, the electric field at the center is. Now I remember, just see, if it would be a complete ring, the field here will be with the same charge. Let's assume the field net would be E due to total charge, if it would have been, would be 0. So what I can say, E due to this remaining ring plus E due to this cut section, that is 0. So what is E due to remaining 1? We can write it is equal to minus of E due to cut section. And because of the small length, I can treat it to be a point charge. So what is the charge on this cut, assuming it has the same density? So I can say Q cut upon Q remaining would be equal to the ratio of their lengths. So that is 0.002 pi, and this 0.5 means 2 pi r, that is 2 point into 0.5. So 0.5, that would be 1, and this pi goes, so it is 0.002. So the Q on the cut would be 0.002 times remaining, that is 0.002 coulomb. And because of this, the magnitude of the field, because of taking it as a point charge, it would be kq by r square. 9 in 10 to the power 9, 2 into 10 to the power minus 3 r square you have as 0.5 square, that is 1 by 4. So 8 9s are 72, 72 into 10 to the power 6, that is what I am getting. So go for option B. So it's a good question. Next one. Let E1 E2 denotes gravitational field at distance r1 r2 from the axis of an infinite long cylinder of the radius r. Which of the following must hold true? Because of the infinite long cylinder, we say it is the same as the line charge. So taking the electrical field analogy of 2k lambda by r, I can also say here E is going to be inverse to r if it is outside. Just remember, if it is outside. So if it is outside, that means if we have r1 greater than r and r2 greater than r, if you have both r greater than r, then what we will have, if r1 and r2 both greater than r and r2 is greater, so E1 would be greater than E2. That is definitely going to be right. So option B we can say is right, but we have to check for all, because all of the above are also given. And if both are inside points, now for inside points, you remember that would be proportional to r, so that in that case that would be also correct. So 2 are correct, so definitely third one will also be correct. Let me check. If E1 is greater than E2, if r is r1 is equal to r minus e, r2 equal to r plus e. Okay, so here if I draw, it would be something, it's like proportional to r and inverse to r, like thing, something like that. So what we'll have, if we have that same distance taken from here and there, you will definitely see the decrement will be more in the case, sorry, let me draw it again. So if we take it like this, it would be what we have, like the gravitational analogy, we can say if we take the same distances here, the drop outside would be more as compared to the inside. So C is also correct. So all of the above are correct for this one. Next, the time period of a satellite of Earth is 5 hours if the separation between it is increased to 4 times. This is question I think 4th or 5th time I'm solving. You know, t square proportional to r cube, t proportional to r की power 3 by 2. So if you do this 4 to the power 3 by 2 means it becomes 8 times, it becomes 40 hours for sure. So that's an easy one. Next one, the radiation emitted by a star A is 10,000 times that of the sun. If the surface temperature of the sun and star are 6,000 and 2,000 respectively, the ratio of the radii of the star A and the sun is. Okay, we know also that radiation emitted H would be proportional to A into t की power 4. So what we'll have, that H of A to H of sun, we have given H of A is H of sun into 10 to the power how many times? 4 times. So H of A would be, let's say it would be RA square, because proportional to R square, area would be into temperature of star A is 2000. So let me draw it. 2000 means 2 into 10 to the power 3 to the power 4 would be equal to 10 to the power 4 into HS. HS would be sun radius, let's say R of sun square into temperature. This is 6 into 10 to the power 3 to the power 4. So what you will have, this 10 to the power 3 thing goes. So what we'll have, RA upon R sun square, first of all, but that would be 10 to the power 4 into 6 to the power 4 upon 2 to the power 4. Okay, so RA by RS now I can write as 10 to the power 2 into 6 to the power 2 upon 2 to the power 2. So that is 36 by 4, that is 9 into 10 to the power 10. So 900 is to 1 that we can go for. So simple application. Next one, An ideal gas is initially at a temperature T and volume V. The volume is increased by delta V. Due to an increase in temperature delta T, the pressure remaining constant, the quantity delta V by V delta T. So this is basically what you can simply say, delta V upon V delta V. Ideal gas, you have what you have, PV is equal to nRT. So if pressure is constant, I can write P delta V is equal to nR delta T. So the delta V by delta thing is nR upon P. So if I do this V both sides, so this comes out as 1 by T. So this thing will be inverse to temperature. So look at the curves. Okay, I haven't taken the proper screenshot. Option C is given like this. So I'll go for option C because it is inverse to T. Next one. An ideal gas is heated at constant pressure and it absorbs Q heat. If the adiabatic coefficient is gamma, then the fraction of heat absorbed in performing the work. So directly you can say at constant pressure, work can be written as nR delta T, Qp is NCP delta T. So the fraction of the heat going into work is simply R by Cp, and you know Cp is gamma R upon gamma minus 1. So it comes out as gamma minus 1 upon gamma, 1 minus 1 upon gamma. So you go for option A. So this is the thing that is generally taught in the theory. Now let's see this. For what we have, let me see this. For C equals to A greater than B, A less than B less than C, the magnetic field at the point P will be 0. So first of all, let me see the figure. Because of this one, the field will be inwards. Because of this one, field will be outwards, and because of this one will be inwards. So the field to be become 0 first due to the first section. Let's say I'm writing B1. Let's say I write it as this due to B1. B1 would be mu naught I upon this angle is 3 pi by 2 upon what I can say, that is 4 pi A. And this is like this. And this is, yes, this is going to be, yes, it is going to be inwards. B2 due to this one. Again mu naught I upon 3 pi by 2, and this would be 4 pi B, and it is again going to be inwards. B3, that is mu naught I, because it is a full loop, I can directly say I by 2C, and this would be inwards. That was outwards. I have written it wrong. That was outwards. Now the field to be 0, B1 plus B3 must be equal to B2 in magnitude. So do this. So what I can have, so I take out this mu naught I thing common. So what, and this pi goes, this pi goes. So what I have, 3 by 8A plus, if I add this is 1 by 2C would be equals to 3 by 8B. And what is C is 2A. So 3 by 8A plus 1 by 4A is equal to 3 by 8B. So taking this would be 8A. This becomes 7. Oh no, sorry, 2. This is 3 plus 2, 5. That would be 3 by 8B. 8 goes. So B comes out as 3 by 5. A comes out as 5 by 3 of B. That is the answer that I am getting. So this is option C. That is going to be correct here. Next one. A current I is uniformly distributed over the cross section of a long hollow cylindrical wire of inner radius R1, outer radius R2. The magnetic field will vary with distance. So it is something like this. So current is, let's say, like this, like this, like this, like this, like this, like this. So applying that Ampere circuitical law for R less than R1, I can clearly make out B is going to be 0 for sure. And for outside one, the current enclosed will remain same. So for R greater than R2, B is definitely going to be inverse to R. So going by these logics, this C rejected, and what we have now, this one. And I know when I come to here, this I enclosed would be very, very small, so it will be starting from 0, it won't jump. So A also goes. Now the option is B and D. So I can clearly say this is not going to be linear, because what I will write, I enclosed would be total I upon pi R2 square minus R1 square divided by pi R square minus R1 square upon that 2 pi R term. So it won't be proportional to R for sure. So this D is also rejected. So I'll go for option B. That is the only appropriate one that is possible. Next one. If a bar magnet of pole strength M and magnetic moment M is cut into 4 times parallel to its axis, and it 3 times perpendicular to its axis, then the pole strength and perpendicular magnetic moment of each piece are respectively. First of all, what we have done, 4 times parallel to its axis. Parallel to axis means like this, 1, 2 and 3, and let's say it is cut into 4 times. 4 times it is cut, that means basically this is 5 times. It should be 4 times. 4 cuts mean it is divided into 5 parts. So that would be what we have, area will become A by 5. And what we have, 3 times perpendicular to its axis. 3 times perpendicular to its axis means like this. Okay. Then the pole strength and the magnetic moment of each piece. So basically this is 5 parts and 3 times means that is the 4 parts. So basically 20 parts you have done. So that magnetic moment, because M was proportional to L, M was proportional to A also. So because of both the things, M will become M by 20 for sure. So first thing is the magnetic moment will become M by 20. Now what we write magnetic moment would be this pole strength into the gap that you call as L. So because here L has become 1/4 and this has become 1 by 20, so pole strength will become 1 by 5. So go for M by 5 and M by 20. You can take that analogy of that electric dipole thing for that pole strength. Next, particle released from rest from a tower of height 3h, time taken to fall equal heights is, that's an easy one. What you can say, equal heights, you know, for first h height you can directly say, just do it like this. This is h, next h. So for this h height I can say h would be equal to half g t1 square, and for this h plus h I can write 2h would be equal to half g t1 plus t2 whole square, t2 be the additional time. Let this time be delta t1, let's say this time be delta t2 or t2, and let's say this time be delta t3. So that 3h would be similarly half g t1 plus t2 plus t3 whole square. Like do this. So what we have t1 is to t1 plus t2 is to t1 plus t2 plus t3. That ratio will come out as root 1 is to root 2 is to root 3. So if you do this t1 is to t2 is to t3, that ratio, that particular ratio will come out as 1 is to root 1 or 1 is to root 2 minus root 1 is to root 3 minus root 2. That is what you are going to have. So this is a standard one. Go for option D. Next one. 2 bullets are fired simultaneously, horizontally and with different speed from the same place. Which bullet will hit the ground first? Okay. So they are fired horizontally and with different speed from the same place. Because they are fired horizontally, uy of both is 0. So both will take equal time to fall. So both will hit simultaneously. Again an easy one. Next one. On a smooth plane surface, 2 blocks A and B are accelerated rightwards by applying a force 15 Newton. If the mass of B is twice that of A, okay, the force on B is. So clearly mass of B is twice of A, let it be M, let it be 2M. So what we can say, 15 is equal to 3M into A because both will move together. So acceleration is 15 by 3M. Now force on B. So force on B you can directly say that is mass of B into A, mass of B is 2M into A is 15 by 3M. So that comes out as 10 Newton. Okay, so that's an easy one. You could do this by other methods also. Next, what we have, a block is given of mass 1 kg, moves on the x-axis. Force affects velocity at t equal to 2 is minus 3. Okay, what is the speed at 4 seconds? So what I can say, from 2 to 4, what is this area? This area will give me impulse. That impulse is that I delta I impulse, that is going to be, impulse is going to be 0, that is change in momentum. So change in momentum is going to be 0. So the speed will, velocity will still be minus 3. So the speed will be 3 meter per second for sure. Next one. The activity of a radioactive substance becomes from 8000 to 1000. That means 1/8 in 12 days. That means this is 1 by 8, 3 t half. So t half is 4 days. So that's an easy one. You can directly pick and choose. Next, the energy equivalent of the substance of mass of 1 gram is. So for 1 gram, what I can say, 1 gram into c square. So what will I write in SI units? That 1 gram would be 10 to the power minus 3 kg. C square is 9 into 10 to the power 16. So it comes out as 9 into 10 to the power 13 joules. Directly Einstein relation you have to use. Mass energy equivalence. Man measures the period of pendulum inside a stationary lift to be t. If the lift accelerates downward with g by 3, then the period of the pendulum will be. So here that g effective, what we write is g vector minus a vector. Because it is downward, it will basically be, what we'll have, it is accelerating downward, so it will basically be subtracted. So it becomes 2g by 3. So what you know, t is proportional to 1 by root g. So t, because it has become 2/3, t will become root 3 by 2 times. So it would be root 3 by 2 times t. So we'll go for option B. Next, particle subjected to 2 SHM along 2 perpendicular direction x and y like this, the motion of the particle will be. Here if you check, do x by y, you see x by y is 3 by 4, that is a constant, so it would be a straight line passing through origin, and here y is 4 by 3x, so slope is going to be 4 by 3. So that's an easy one. You can do simply by dividing them. Next, Wavelength of characteristic X-ray. Again a question from X-ray, depends on which property of target. So wavelength of characteristic X-ray depend on the Z. Next one. The work function of three metals A, B, C are W, A, W, B, W, C respectively. They are in decreasing order. The correct graph between kinetic energy and frequency is. So first of all, what we have, decreasing order. That means A has maximum, so its cutoff frequency will be maximum. So it is wrong. So this one seems to be the appropriate. Okay, this one seems to be appropriate because all will have same slope. Ideally it should not be like that. This C, it is appearing like threshold frequency is 0. It should be slightly shifted, but out of the available one I think B is the most appropriate. Next one. Two water pipes having diameter this and this are joined in series with the main supply. The velocity of water flowing in pipe P is. So what we have, diameter is doubling, that means area is becoming 4 times. So area becomes 4 times, so what we'll have, the speed will become 1/4. So in the P, the speed will be 4 times that of Q, because P is the narrower one, it has 4 times that of Q, simply using that A into V remains constant. Continuity equation. Next. Hydraulic automobile lift has input and output piston of this. The lift is used to hold up a car with weight this. What is the force? So simply what we have, F1 upon A1 is equal to A1 equal to F2 upon A2. That is the Pascal's law. So that F1 required would be, F2 uses 1.44 into 10 to the power 4. A1 by A2 would be D square. That is 10 by 30 whole square. That is 1 by 9 of that. So if you divide it by 9, it will be, what you will have, it would be 0.16 into 10 to the power 4, or you can write 1.6 kilonewtons. So 1.6 kilonewton, that is the option A you will tick for. Next one. If the distance between the virtual image from its real object is 60 in case of a concave mirror, focal length of the concave mirror if the image formed is 3 times magnified image. We have done this yesterday also, probably in the JEE main thing, because it is 3 times magnified. Okay, and virtual image, that means object is between pole and focus. So what we will have, object is here and image will be somewhere here, like this. So I can make out, let's say this distance be mod u and let's say this distance be mod v. So mod v plus mod u, that is equal to 60, and mod v by mod u is known as 3. That is, you can get, so here from u directly you can say mod u is equal to 15 centimeter, mod v is 45 centimeter. So the focal length would be, using the result, 1 by v plus 1 by u is 1 by f, and as per convention v will be positive but u will be negative. So 1 by f is going to be minus 2 by 45. So f is minus 45 by 2, minus 22.5 centimeters. Go for D. Next. Two thin equiconvex lenses, each of focal length 0.2 meters, are placed coaxially with their optic centers 0.5 meter apart. The focal length of the combination is. So you directly remember 1 by f equivalent in this separation case is 1 by f1 plus 1 by f2 minus d upon f1 f2. So simplify this, which is 1 upon 0.2 plus 1 upon 0.2 minus 0.5 upon 0.2 into 0.2. So what you have, this will become, this is 5 plus 5, you can write like that, and here what you will have, 25 into 0.5, that is 12.5. So it is 10 minus 12.5, that is minus 2.5. So focal length equivalent would be minus 1 upon 2.5. That is what you can write, that is minus 0.4 meters I can write. So go for option A. Next one. Uniform disk of mass m and radius r is hinged at its center C. Force F is applied on the disk as shown. At this instant the angular acceleration of the disk is. So first of all, torque. If I have to calculate the torque, I need to calculate this perpendicular distance. So what I can find out from here, this is r and this is 240 degrees, so the remaining angle is 120, and this would be bisector, that is 60 degree. So that perpendicular distance, this r perpendicular, is going to be r cos 60, that is r by 2. So torque is equal to fr by 2, and that is I alpha would be mr square by 2 because it is a disk into alpha. So alpha is going to be 2 goes, rr goes, it is going to be f by mr. So it is going to be f by mr. So we'll go for option B. Next one. Two balls of masses m and 4m are connected by a rod of length L. If the mass of the rod is small and can be treated as 0, the size of the ball also can be neglected. We also assume the center of the rod is hinged, but the rod can rotate about center in the vertical plane without friction. What is the gravity induced angular acceleration of the rod when the angle between the rod and the vertical line is theta? Okay, so again you have to first find out the torque. So we have hinged it at the center. Okay, so this would be 4mg, this would be mg, so both would be in opposite sense. The torque of 4m would be 4mg into, if I take this perpendicular distance, this angle is theta, so this angle is theta, so I can say it is L sine theta. So 4mg into L by 2 sine theta would be equal to, similarly here also you will have that would be equal to mg L by 2 sine theta. So L by 2 sine theta, L by 2 sine theta go, okay, sorry, net we have to subtract and calculate. So it would be 4mg minus mg, directly I can say, into L by 2 sine theta, that would be equal to I alpha. I is what? It would be 4m into L by 2 square plus m into L by 2 square times alpha. So what you have, this is 3mg L by 2 sine theta. This comes out as 4 ml square by 4, that is ml square, plus ml square by 4, that comes out as 5 ml square by 4 into alpha. So m goes, alpha comes out as, this comes out as 6 by 5 g sine theta by L, I suppose. So 6g by 5L sine theta as per the option. This is C1 is coming, so I think that should be correct. Yes. Next. Two identical PN junction may be connected in series with a battery in 3 ways. Okay. The drop across two are equal in, definitely when both are forward biased. So when both are forward biased, that is in option 1 I can say. In only one we can say like this and nothing else. In one, or yes, in one only I think. Sorry, one, no, it is circuit 2. Also, if both are reverse biased, what I can say, this would be, if both are reverse biased like this, again no current is flowing, that means the potential drop across them. So also, as per available option, you have to treat here also that it would be half of that. So I can go for circuit 2 and circuit 3, but circuit 2 was sure and circuit 3 also, because you cannot differentiate, both are not having any current, so it's almost same for both. Next, a reverse bias diode is, okay, what is the reverse bias diode here? -6, -3, definitely it is lower, so it is reverse bias, sorry, it is at a lower potential, definitely P1, so it is a reverse bias one, so go for option A, no need to check further. Next, liquid of density, this flows through a calorimeter at this rate, heat is added by a means of 250 watt electric heating coil, potential difference is established in steady state condition between the inflow and outflow points, the specific heat for the liquid will be. I think this flow calorimeter problem I have done before also in some NTA test. Now what it is coming is, first of all, it is flowing at the rate of this, so you can find out what is the mass flowing rate, and this is heat is added and temperature difference is being maintained. So that means the heat is added, so temperature difference 15 degrees, so that ms into 15 degree, that is what it will be having, that is equal to the power supplied, dm by dt, I can write dm by dt as 15 degrees Celsius, that would be equal to power supplied. So what you need to find out, specific heat, that would be power 250 upon 15 into this dm by dt thing. So what is the mass flowing per unit time, that is 250 by 15, and this was what, dm by dt. So dm by dt, what I can write, dm by dt will be, this is dm by dt is volume at rho into dv by dt. Rho is 0.85 gram per centimeter cube, so I should write it as 850 in SI units, and this is 8 centimeter cube, that is 8 into 10 to the power, we know centimeter cube to meter cube, that would be 10 to the power minus 6. So this is the specific heat in SI units. It comes out as 250, this comes out as 10 to the power 5, this comes out as 15 into 8 into 85. This would be joule per kg per Kelvin. Now if you do this in kilocalorie, so for kilocalorie you have to, first of all, kilo, this is 10 to the power 2 remains, and now divided by 4.186 as per this, into 15 into 8 into 85. So what you have, 15 8s are what you have, 120, so 120 250, and this is 85 into 10 to the power 2. We have to do the calculation, it is not going to be that easy. So let's try, let's cancel it first. This is 50, this is 3, so this is 50, that is 5000. What we have, 24 into 85 into 4.186. So 24 into 85, if you do, this will be, and let me try, or first 224 into 4.186, so it would be roughly 100, so it would be roughly 8500. I'm doing an approximation, so this is 5000 by 8500, so it would be approximately greater than, definitely greater than 0.5, so it is 0.6 kilocalorie per kg per Kelvin. You can try your calculation. I have done through my approximation. Next, the pressure on a square plate is measured by measuring the force on the plate and the length of the side of the plate. If the maximum measurement error are 4 and 2% in force and length, okay, pressure is force upon area, that is a force upon L square, so maximum errors you directly say is delta F by F plus 2 times delta L by L. So what do you have? Delta F by F, that is 4%, this is 2 to 4, that would be what you have, 4 plus 4, that is going to be 8% for here. You can directly do this. Next one, in a single slit Fraunhofer diffraction pattern is formed when white light, for what wavelength of light, the third secondary maximum coincides with the second secondary maximum in the pattern for red light. Okay, so second secondary maximum, that is 5 by 2 lambda red L by A, that coincides with third secondary maximum, that is 7 by 2 lambda L by A. So that lambda definitely is 5 by 7 of lambda red. So 5 by 7 of lambda red, 5 by 7 into 6500. So this comes out as 7 9s are 63. Then you have 20, that is 2, then 60. So 9, 28, 29 you can have. So it is approximately 5 8s are 40. 5 2 10 14. This is 4640 roughly, that is 4642 angstrom, that is going to be B. In YDSE, the intensity at a point where the part difference is lambda by 6 is I. If the ratio of I by I naught, what you can say, I would be at any point I is I naught cos square phi by 2, and phi is 2 pi by lambda into lambda by 6, so it comes out as 2 pi by 6 or pi by 3, so this is pi by 6, so I would be I naught cos square of pi by 6, cos square 30, that would be 3 by 4 of I naught. So the ratio comes out as A option you can do for. Okay, next one, so not a tough one this one. A siren emits a sound of frequency 800, moves away from an observer towards a cliff at a speed of 15. Then the frequency of sound that observer hears in the echo reflected from the cliff. Okay, because it is moving towards a cliff, first of all, cliff will hear a frequency which is 800 into 330 upon, because it is moving towards it, minus 15. So that is 800 into 330 by 315. If I divide it by 15, this is 21 and this is 22. So it is 800 into 22 by 21. Leave it here. Now when it is reflected, this will act as the source, that would be 800 into 22 by 21 is the frequency original, and now because it is moving towards it, it would be 330 plus 15 because it is observer upon 330. So now what you will have, 800 into 22 by 21, and here you will have 23 by 22 now by 15. So this 22 goes, so 800 into 23 by 21. So that is, you can say 800 into I can write 1.21, but this would be 1.2320. It would be 1.09 or 1.1, so it would be close to 880, and not close to 880, it would be like 23 by 21, so it is 1.09. Okay, so it should be close to 880. I'm not getting this. As per me, it is close to 876. That should be the answer. So tough to comment. 885 is also higher, 838 is lower. So I think there's some issue in it, and what they have done in the solution, they have forgotten to add this plus 15. They have written, but they haven't added it. So it's a mistake on their side. Next, an observer starts moving with uniform acceleration towards a stationary sound source of frequency f0. As the observer approaches the source, the apparent frequency heard by the observer varies with time is. Okay, starts moving with uniform acceleration towards a stationary source. So let's say this is the source and observer is going like this with a constant acceleration. So what we only concerned with the velocity, what we can say f apparent is f0 into v plus v of observer. V of observer would be, let's say, u plus at upon v. So it is definitely going to be a linearly increasing function. So going by the option, it would be D, nothing else, because the velocity will increase linearly. You don't need to go about the separation. Separation is not important, only the relative speeds are important. Now the last, bead of mass m can slide without friction on a fixed circular horizontal ring of radius 3r. Having a center at C, the bead is attached to one of the ends of the spring of constant k, natural length is r, and the other end of the spring is fixed at O. If the bead is released from A, then the kinetic energy when it reaches B is okay. So now the radius is 3r. So because radius is 3r, this is 4r, so initially OA length you can make out is 5r. So initially if I write this energy of the spring, it would be half k. Its original length was r, so it is stretched by 4r, and kinetic energy is 0. And we know that the energy will remain conserved. It is horizontal, no vertical angle. So finally when it comes to B, at B I can make out that OB distance is equal to r, that means U final is 0. So I can directly say the loss input is spring energy, which is half k into 4r whole square would be equal to half m v square. So you have to find only the kinetic energy. So kinetic energy would be this. This comes out as what? 8 kr square. You need not to calculate even the velocity also. So question was looking tough, but it was not that tough. So it was today's paper. So do send in your comments and do fill the type form given in the description to get the PDF of this paper. Thank you once again.